All right, so we started this chapter by looking at our quadratics, which are actually a specific type of polynomial. And so now we're going to look at just some general polynomials instead. So remember that a polynomial is going to be anything that has integer exponents and they have to be positive. And then they also have to have real number coefficients. So those are the main two things that we're looking at when we're looking at polynomials. So we're going to look at some characteristics of polynomials and their graphs. And so the first is going to be our end behavior. And so in this example, we have two different types of graphs that we're looking at. The first is where we're pointing down on the left side and up on the right side. And then on the second, it's basically the opposite. So we're pointing up on the left side and down on the right side. Now, the important thing here is that we are going to use the notation that we see there, which is our f of x and our infinity notations. Now, hopefully we've seen this type of notation in Algebra 2, but if we haven't, let's just do a quick little review. So remember that we have basically four different directions that we're talking about. We're talking about directions on our x-axis and also directions on our y-axis, or f of x. So as we go to the right, notice that our x is going to be going towards positive infinity. And as we go to the left, it's going to be going towards negative infinity. As we go up, we're also going towards positive infinity. And as we go down, we're going towards negative infinity. So basically, we're trying to come up with the combination of those that we're looking for. So in this case, because we're on the left side of our graph and we're pointing down, we're going to say f of x is going towards negative infinity as x is going towards negative infinity. When we're on the right side of our graph, x is going towards positive infinity, and we're pointing up. So f of x is going towards positive infinity as well. On our other one, notice that on the left side of the graph, this time I'm pointing up. So I'm still on the left side of my graph, so my x is still going towards negative infinity, but because we're pointing up, now f of x is going towards positive infinity. And on the right side, we're the opposite. So x is going towards positive infinity, but because we're pointing down, f of x is going towards negative infinity. Now, hopefully we notice that these are both opposite ends. So one's pointing down, one's pointing up. And this is going to be the case when we have an odd function. Okay. And the way we know which one it is, so our leading coefficient, remember, is the coefficient of our first term as long as we put them in descending order. So we want to put the biggest exponent first, and then that's the coefficient we want to look at. So if our leading coefficient is positive, then our graph is going to look like this. So the left side's going to go down, the right side's going to go up. Whatever happens in the middle happens in the middle. We're not too worried about that when we're talking about end behavior. And then over here is when our leading coefficient is negative. And both of these, again, are for an odd function, which means that the degree, remember your biggest exponent, is odd. Now, on this one, basically, we're still looking at end behavior. So notice that I have my left side of the graph, so x is going towards negative infinity. We're pointing up, so f of x is going towards positive infinity. And also on the right side of the graph, f of x is going towards positive infinity as x goes towards positive infinity. And then on our other one, both of them are pointing down, so both of my f of x's are going towards negative infinity for the left and the right side. So notice here that both of the ends are pointing the same direction. So this is going to be for an even function. So remember, by even, I mean that the degree, or the biggest exponent, is even. And on this one, our leading coefficient is positive when they point up and negative when they point down. Okay, so it says describe the left and right hand behavior of the graph. And again, I want us to use that correct notation. I don't want us to just say up or down. I want us to talk about the f of x's, the x's, and the infinity symbols. So on our first one, we want to start by saying if it's an odd or an even function. So this one is going to be odd. And notice that our leading coefficient is -1. So that tells us that our ends are going to be opposites. So we want to look at our odd options. And we know that my leading coefficient is negative, so I know that the left side is going to point up and the right side is going to point down. But again, we don't just want to say up and down. We want to use that correct notation. So I'm going to say f of x goes towards, that's what the little arrow means, positive infinity as x goes towards negative infinity, because I'm talking about the left side. And then we would say f of x goes towards negative infinity as x goes towards positive infinity. Now on the next one, notice that our degree is 4, which is an even number. So that means that we have an even function, and our leading coefficient is 1. So I'm going to look at my even options. Notice that our leading coefficient is positive. So that means that both of them are going to have to point up. And again, we want to use our correct notation. So I'm going to say f of x goes towards positive infinity. And notice that it's going to happen as x goes towards positive or negative infinity. So if they're doing the same thing, I'm okay if you just write it as one statement, and instead of having to write it as two different statements. So then on our last one, our degree is 5. So we have an odd function, and our leading coefficient is 1. So basically, we're going to have the opposite of what we had a second ago. So we're going to point down on the left, up on the right. So we have f of x goes towards negative infinity as x goes towards negative infinity, and f of x goes towards positive infinity as x goes towards positive infinity. So if I ask you to describe the end behaviors of a graph, this is the notation that I'm wanting us to use. So if we do not use this notation on a quiz or a test, I will take off points for it. So please make sure that you're using the correct notation. And if we don't understand it, that we're getting help, we're asking questions, and that we are reviewing it to make sure that we do understand it. All right, so looking at zeros, specifically real zeros of a polynomial. So it says, if a polynomial function, if f is a polynomial function and a is a real number, the following statements are equivalent. X equals a is a zero of a function f. X equals a is a solution of the polynomial equation f of x equals 0. X minus a is a factor of the polynomial, and a comma 0 is an x-intercept of the graph. So all of those things mean the same thing. It's just a slightly different way of asking it. So whenever we see those types of things, we know that we're basically looking to do the same thing. So let's look at an example. So it says finding the zeros. So when I'm finding my zeros, I'm wanting to use kind of the same technique that we found earlier this year. So if I want to find all of the zeros, I'm going to set my function equal to 0, and then we're going to solve for x. Our first goal is always going to be to try and factor it. And then we're going to look at a little bit later what happens if we can't factor it. In this case, we can factor it. So we have 0 equals, I have a greatest common factor of 2x squared, which leaves me with a negative x squared plus 1. So then I'm going to set each of my factors now equal to 0. So I would divide by 2, take the square root, so we just get 0. Here I'm going to subtract 1, divide by 1, and then take the square root. But be careful on this because remember that when we take the square root, we have to add a plus or a minus. Now, an important thing to remember from our Algebra 2 is that any polynomial has to have the same number of zeros as our degree. And that might be a little tricky in this case because notice I have positive 1, negative 1, and 0, which is technically only 3 zeros. However, notice that because I have a squared here, technically 0 is repeated twice. And so we would say we have positive 1, negative 1, and then 0 happens 2 times. So those would be our 4 zeros. So we know that we found all of them. All right, so on our next graph, we're going to, on our next problem, again, I'm wanting to find the zeros. So remember that we want to start by setting our function equal to 0. And then we want to factor if at all possible, which in this case, we have a common factor of x. So I'm left with x squared minus 2x minus 3. So we have a quadratic here. So we're either going to need to factor this or we're going to need to use our quadratic formula. So looking at it, our c value is negative 3. I don't have an a value, so we're just looking for two values that multiply together to give us negative 3, that add together to give us negative 2. Which is going to be a negative 3 and a positive 1, which means that my values are going to be 0, 3, and negative 1. All right, so like I said before, sometimes we have repeated zeros. And what that means for our graph is that it's going to do something a little bit different to it. So if a factor is repeated, and it has a multiplicity of k. So k is just going to be whatever that exponent is. So when I talked about our 0 a second ago, remember that it had a x squared there. So your multiplicity would be 2 in that case. So if k is odd, it's going to cross the x-axis. If k is even, it's going to just touch the x-axis. And so let's look kind of at what I mean by that. So notice here, on my graph, it's a little bit hard to see, but I have x minus 3 quantity squared. So because it's squared, it touches the graph, the x-axis, and doesn't do anything else. Now notice if I change that squared to, say, a fourth, it still touches the graph on the x-axis and then comes back up. But notice if I change it to a 3, now it crosses the x-axis, or in other words, it goes through the x-axis. And that's going to be true for any odd value. So I changed it to a 5. It still goes through my x-axis. And this is going to be true no matter how many factors we have. So I'm going to leave that x minus 3 to the 5th. And I'm going to add in, let's say, an x plus 2 squared. So now notice that we're just going to touch and come back down at -2. But then at 3, it still goes through it. And that's going to be the case no matter how many zeros we have. If we can write it with like an exponent out to the outside, that's going to tell us what that's going to do to the graph. Now, remember, if there's not an exponent out to the front of it, it's an understood 1. So if I just delete that exponent, notice at -2, it still touches it and comes back down because it's still even. And then at 3, it still goes through it because even though I don't have an exponent, I have an understood exponent of 1, which is still an odd number. All right, so now let's put all of that stuff that we just talked about together. Okay, and we're going to try and sketch a graph. So I have f of x equals -2x cubed plus 6x squared minus 9 halves x. So the first thing that we're going to need to do is to find our zeros. So we're going to set our function equal to 0. Okay, and we want to solve this. Now we want to solve this first by factoring, if at all possible. And if we can't factor it, then we shall try something else. So notice that we do have a common factor of x. But we also want to make our lives a little bit easier and factor out try and factor out something so we can get rid of this fraction here, which is a half. So I'm going to go ahead and factor out a 1/2 x. Now, remember that when we're factoring, we are, so this x is on the outside, sorry. We're dividing. So we need to be careful about this because when I factor out the x on my first one, that means that I'm left with x squared. But we're not factoring out a 2, so I'm not left with -1. I'm factoring out a 1/2. So we would have to do -2 divided by 1/2. And remember that when I divide by a fraction, I'm going to multiply by the reciprocal. So off to the side here, I'm going to show you what I mean. So remember, if I have -2 divided by 1/2, remember that instead of dividing by a fraction, I would keep my first number, change to multiplication, and then flip my second number. So this would become -4. So that's what's going to be left on the inside there. And that's a 4. And the same is going to be true for my 6. We would have 6 divided by 1/2, which would become 6 times 2. So we get 12x. And then here, because we're factoring out, we just get a -9. So then we have a quadratic. So we need to decide what that's going to factor to. So we have a -4 times a -9, which gives us 36. So we're looking for two numbers that multiply together to give us 36, that add together to give us a positive 12. And so it's going to be 6 and 6. So we would have -4x squared plus 6x plus 6x minus 9. Then we do our factoring by grouping. I'm going to go ahead and use a big grouping symbol. I can factor out a -2x here, and I'm left with 2x plus 3. And I can factor out a positive 3 here. Sorry, I forgot to flip my sign. This should be a -3 there. And then I'm left with a 2x minus 3 as well. So now, having all of my factors, I have 2x minus 3 times -2x plus 3. So that means that my zeros are going to be 0 and 3/2, because I would add 3 divided by 2. And then here I would subtract 3 and then divide by a -2. So I also get 3/2. So that means that I'm going to have a 0. That's 0. And then also 3/2, which is going to be 1.5. So that gives me a little bit of information about my graph. But the other part of the information that we need is, remember, our first thing that we talked about was our end behaviors. So I have an odd function, and my leading coefficient is negative. So that means that on the left side, we're going to point up, and on the right side, we're going to point down. So again, that just gives me a little bit more information about my graph. And basically what we're going to do now is to pick some numbers, plug them in, and that's going to give us kind of the shape of our graph. So, looking at our graph, we want to pick numbers that are in between each of the kind of areas that we're talking about. So notice that our x-axis is broken up into 3 different kind of areas. So we have one that's before 0, in between 0 and 1.5, and then after 1.5. So I want to pick numbers that are going to fit into each one of those categories. So like my first number, I could pick, say, -1. I want to plug that into my function. So we would have 1/2 times -1 times 2 times -1 minus 3. I'm running out of room, and so forth. And then we're going to evaluate that. And then we also want to pick something that's in between 0 and 1.5. So say 1, and then after, so that's going to be 2. And we're going to plug all of those values in. And I'm going to go ahead and use a graphing calculator and go ahead and just use the table function. You can also use the table function on your scientific calculator. It'll work as well. But I wouldn't waste the time of just plugging stuff in manually because I know that y'all know how to do arithmetic, which isn't what we're trying to get at here. So if we plug in -1, we get 12.5. If we plug in 1, we get -0.5. And if we plug in 2, we get -1. And so I'm going to plot those points. So -1, 12.5. It's going to be like way off my page. And then I have 1 -0.5. And then 2 -1. Now, the other thing that we need to take into account are multiplicities of our zeros. So notice that I don't technically have a squared here. However, if we went ahead and factored out a negative from this one, notice that the other way this could be written would be -1/2 x. Then this would become 2x minus 3. So we would get 2x minus 3 quantity squared, which is why we ended up getting 3/2 twice. So remember from our last page, if it has a multiplicity that is even, which 2 is even, it's going to touch it and then come back down, which means that I know at this point it's not going to go through, it's going to touch it and then come back down, which is good because on our right side, our graph needs to continue going down. So notice on our left side, we're going to come down. We're going to go through our 0 because it has a multiplicity of 1. I'm going to come through my point here. I'm going to go back up. It's going to touch it and then come back down and end pointing down. And if we needed to get a little bit more accurate of a graph, we could plug in some more values, but that's going to give us the general shape. So using all of those kind of characteristics that we talked about using them to figure out our graph. And then also picking those key points in each of the intervals that it's broken apart into by the zeros of our graph. All right. So our last thing that we want to look at is what's called our intermediate value theorem. Now that sounds like a fancy thing, but it's actually not. It's pretty straightforward. Basically, what it's going to say is if I have two numbers or two x values that give me a positive y value and then a negative y value, I know that there has to be a 0 somewhere in between there. So if we were to look at this and we wanted to find our zeros, notice that this does not factor. And we haven't talked about any other ways to look at it or to find zeros yet, which we will be getting into. So if I wanted to just start plugging and chugging, I have x and I have y. Let's go ahead and start at 0. So notice if I plugged in 0, I would get 1. And if I wanted to then plug in, let's say, -1 and a +1, again, just using my graphing calculator, because we don't need to spend the time doing that by hand. So then if we plug in -1, we get -1. If we plug in -2, we get -11. Going the opposite direction, if I plug in 1, I get 1. If I plug in 2, I get 5. And then it just keeps going up from there. So let's take a closer look and notice that I know that somewhere in between 0 and -1, we had to cross our x-axis. So because if I go from a positive y to a negative y, my intermediate value theorem says somewhere in between there, I had to cross. So let's go ahead and look at -0.5. I'm going to have to change the step value. And I get 0.625, which is still positive, which tells me that my 0 has to be somewhere in between -0.5 and -1. So if I keep going, let's say I wanted to plug in -0.75, so a little bit closer, I get 0.01565. And we could keep going, taking a half and a half and a half. And we could be doing that all day. However, I'm going to go ahead and stop there. We have 2 decimals, which is good. So I'm going to go ahead and say that we are at approximately -0.75. And then that was the only place that we changed from positive to negative or negative to positive. If we had another one, then we could continue to do that. But we're going to say that our 0 is there.